Okay, welcome everyone. This is going to be a fairly technical talk. There's absolutely no mathematics in it. So I've been playing in the past month a little bit on the build system, and so let me. So I don't have slides. I'll just show you some things that are happening here on my screen. So let me start with telling you a story about how Sage distribution has developed in the recent years. So traditionally, Sage distribution was kind of like a monolithic system, so bringing its own compiler, bringing all packages by itself, and so by doing that, of course, one has a lot of control. Yeah, so we can pick exactly the right packages, and we can make sure that everything fits well together. And so somehow the idea, and so that's also how many people used to use Sage distribution, is to use it like that, like a distribution of really finely tuned and a lot of mathematical software and so on. And I suppose at one point one might think that Sage is big enough that it can absorb the entire mathematical Python world under the Sage umbrella. But things have changed. Mathematical Python has grown exponentially. Sage has, let's say, grown linearly. So I mean, we are a project in a very good shape, but there's a lot out there. And it's just not feasible anymore to say, okay, we have this closed system here. Sage has everything that everyone needs, and so on. So people have a lot of other Python stuff that they need. So the question is, how does one deal with that? So a couple years ago, so I guess 2017, there were a number of so you can probably see where I'm pointing here. Yeah, there were a number of discussions on Sage Devel. What can be done about this? Can we, for example, use more system packages so that Sage doesn't have to build all of these S packages, but rather detect what's out there in the system already installed from Debian or from whatever OS package manager you're using. And so this is what happened. So a number of people have worked on this, and so there's the first ticket that made this happen. So there was a first mechanism. So this is called the S package configure mechanism. So it's something that supplies code to the configure script, so the script that we run at the beginning of the build, and in order to detect what pieces of the system are available. So this happened something like 3 years ago. So this was here started by Eric Bray, and so there's a meta ticket that has gone on since that time, like 8.x releases, that is really long. That basically there's, for every one of our hundreds of packages, there's now a ticket that adds these facilities to detect whether there's a suitable version of that thing already installed in the system, and so that we can use it. Yeah, so these are some of these tickets are easy tickets, some are rather complicated tickets, because in a user system there can be a lot of stuff, and basically telling the useful bits from kind of dangerous old versions of libraries and so on is really tricky business. The intention of having these things really to make build times of Sage distribution shorter, and perhaps the installation size of Sage distribution shorter, and perhaps in the end to have Sage integrate more tightly into a typical system, and in the end also integrate better with other Python code. So, but so you see, this goal, of course, should not sacrifice all of the things that had been, all of the good things that had been achieved with Sage, namely the fine tuning of all of these packages and so on. And so one needs to be really careful there. And so then the question is, how can one be very careful there? And the answer is one needs to test a lot. Yeah, and so so testing, how is testing traditionally done in the Sage world? Well, we have a number of automated build bots that build things on maybe a dozen platforms or so. So someone installed these servers. They have a particular configuration, and the automated builds and tests are run for each Sage version. And okay, so it's built there. And of course, developers are testing. RCs come out, developers test, and then after some turnaround, there's reports what works, what doesn't work, and so on. So, so this served Sage really well in the past, but now with this additional variation that is coming in to the fact that we're detecting system packages, basically this didn't scale. Yeah, so we didn't magically get more and more developers who are doing this testing. Yeah, but so this more or less stayed a constant. Yeah, but we were increasing the variation of kind of system configurations that we need to work with. Yeah, and so this is something that I was working on in the last few months a little bit, and in particular, this is something that came out of a particular frustration with one of these S-package configure mechanisms that I decided to work on. So one package that was not done in Sage 9.0 was Python 3 itself. Yeah, so we would always build our own copy of Python 3. And as a corollary of that, we were never able to use system Python packages in any way. Yeah, so we have our own Python 3. We have our own setup tools. We have everything, and then we install the whole machinery of Python packages that we need on top in our Sage local hierarchy. And so since Sage 9.1, we now have this S-package configure mechanism for Python 3. But while I was working on this, there was kind of endless frustration. I had lots of trees, and I was getting really confused. I just couldn't make sure that there's sufficient coverage for all of the ugly corner cases. Like on Mac, there are different versions of Python 3 that you get. There's the one that comes from Xcode. There's the one that users might have from upstream, from Python 3, from python.org. Then there's what comes from Homebrew, and then there are the various Linux variations, and so on and so forth. So out of this frustration, I stopped with this Python 3 S-package configure ticket and looked a little bit into what can be done about basically testing on multiple platforms. So the key to this, so there are many approaches that one can do. Of course, one could say, okay, let's somehow provision a really comprehensive build farm. Let's set up 100 servers in various configurations and so on and so forth. But we don't really have the human power to do that and maintain that. Yeah, so therefore, what I was looking for was a system that, first of all, works without let's say infrastructure, so without running our own servers of anything, and moreover also that software system configurations do not have to be maintained. Yeah, and so I'm going to tell you a little bit about the solution that I developed there, and so this is something that first of all, it builds on a testing solution that is pretty widely used in the Python world. It's called Tox. So Tox is really just a system for running various tests. And so it's originally meant to run Python package with various different Python versions and Python configurations, but it can really do anything. You can run arbitrary arbitrary shellcode with it. And what Tox can do, it has a really nice pattern matching language. This is something called Tox factors. And so this is something that I use to describe particular system configurations. And I'll just show you this as a kind of black box example first. So what you can do, just on your computer, there are no servers involved, is to can you all see this terminal well? Some reactions. Yeah. So I'm now here in the root. So in the Sage root of some tree. I'm here in a work tree, but this doesn't matter. And so somewhere here you see my is my configure. Yeah. So and I've got a lot of trash in this tree as well. Sorry. So there's the bootstrap script. Here's the build directory, and here's the source directory with the with the Sage source tree. And what is new there is this file tox.ini, which is the master file for this kind of testing. And what I have on my system, in this case, I'm getting this from Homebrew, I guess. I have a tox, so I have a user local bin tox. That is something that one needs to install in the system. And now I can invoke this and I can say the following thing. And I can say, so by the way, so you can probably see this from my window decoration. I'm here on macOS. Yeah, but let's perhaps say I want to test Sage on maybe I want to test this on some Fedora Linux. Yeah, so I can go and I can say -e. That means environment. So this is Tox jargon for a particular system configuration that I wish to test. And so I can write the following thing. So I'm going to write docker dash. So that's one of these configuration factors. And so that means I want to use Docker actually as a technology to to run this test. So there's something else. I'm not sure if I'll have time to explain that other technology. It's called local. Let's just stick with Docker. And then I can say Docker, what did I say? Fedora, maybe I do Fedora 30. And I want to run this with kind of a standard set of installed packages, and I'll explain later what that exactly means. So let's just do this, yeah. And then I type dash, and after that I have various options that I can do, and so. So let's just build a little a thing. Let's not build the whole of Sage. Let's just build one little package. Let's maybe build lrslib. Okay, so why not? Yeah, and so let's see what's happening now. So Tox is starting to talk. Okay, so it's talking about this environment, Docker Fedora 30 standard. Then it is talking to the Docker daemon. And so what happened here behind the scenes is, so Julian in the previous talk showed you a particular Docker file. I also have a Docker file here, but this Docker file is actually automatically generated. So in the moment that I call this tox here, my tox script in tox.ini, I'll show you later, this generated a Docker file. And this Docker file, it creates, it uses the from command of Docker files to pick up an operating system, Fedora. So here the default is Fedora latest, but through arguments, I actually plugged in Fedora 30. You don't see it, it's somewhere hidden in this command line here. And so it's pulling that from the server. Yeah, so this one here is the SHA-256 digest of that image. So it's now on my computer, and then so something here computed a list of names of system packages. There's, for example, in Fedora they have the naming scheme -devel for like development packages, those that have the header files and so on in there. And so something here computed here this list of packages, and then it runs yum, which is the traditional tool on Red Hat type distributions to install stuff, and it then installs all of that stuff. Yeah. So so here you can see we are on Fedora 30, and so it's doing that. Yeah. So installing this stuff. Scroll further on. So this is all running on my MacBook here. Yeah. So this is Linux. Yeah, but it's running in a Docker container that was set up here. Yeah, so it's like 887 packages, and it's still downloading them. If one does these kinds of things, oftentimes there are some things one should know. First of all, so Julian didn't mention this, but Docker has a very sophisticated system for caching certain things. It has a particular layered and hashed file system. Basically, when you you can set up an image based on an image, based on a container, based on an image, and so on. And when you make little changes, then there's a way that only like the incremental changes to the file system are saved. And so you can have kind of small incremental file system layers. So you can keep overall sizes of images rather small. And so that's one of these really nice facilities in Docker that help with that. And so then the second thing, these package installations here, yeah, so they query the distribution servers, and if one does this lots of times, and in particular if one does this at home, so I am right now in my office in the university, so I have a really fast connection. But if one does this over just a DSL connection, there's some benefit from setting up a proxy server on the machine, so that this takes a lot of the required network bandwidth away. Okay, so while I talked, it's went all the way to installing number 434, I guess, of these packages, 435 and so on and so forth. Okay, I need to talk a little bit more. Yeah, so it's still somehow preparing for the installation of Sage. So it's really just, it's setting up from scratch. Okay, so what does from scratch mean? Maybe I'll explain that. Let's look a little bit into tox-ini while the terminal is busy. So in this tox-ini, so everything we need to know is in this tox-ini. And actually there are also things there that you definitely don't want to know. Okay, so let's see, where does it start? Basically for major Linux distributions, I have here nicknames of basically the Docker images that are available. So for example, right now we were doing Fedora 31, and so I have a particular system here. Fedora 31 is constructed as a base image being Fedora, and then the base tag is 31, and I put this together so this becomes Fedora:31. And in a similar way, I have various other distributions. For example, here's Ubuntu. So Ubuntu has these images that are called, Ubuntu : and then the nickname of the particular version. So there might be Ubuntu Focal. That's the latest Ubuntu that just came out recently. Yeah, so there's Debian and so on and so forth. Yeah, so I have here basically a mapping from names that I can use in tox to describe a system configuration to a name of the image on Docker, because one wants this mapping because it's every distribution has their own little scheme, their own little naming scheme. For example, we can look on hub.docker.com for Ubuntu. There one can see what things are named. So we see here, for example, so focal here. Okay, that's a Docker file. Anyway, so you can see here the names of these tags. But for some other distributions, they use different naming schemes, and so I have this mapping in my tox.ini. So, for example, here I have Linux Mint. It's a Debian variant like Ubuntu. So they have a Linux Mint 19.1, and so one needs to get this Linux Mint by doing the image Linux Mint d slash and then the particular name here Mint 19.1, and then one takes the tag latest in that. So it's a different naming scheme, and so it is something that I am abstracting away by doing this mapping here that I have in this thing. So Fedora, we already looked at. Arch Linux have just Arch Linux latest. So here's Slackware. Slackware lives in Docker. So let's take a look at this one here. It's all on Docker Hub. And so these are pre-built operating system images. So I'm not building the operating system there. I'm just getting this image, just like Julian showed, getting this image, and then we are building stuff on top. And so here's what one could do for Slackware and for any other distributions. And so I have this mapping now from from my nicknames to the actual Docker things. So that's one of these abstractions that I'm building there. That so that one doesn't have to remember the particular naming scheme of a particular distribution. Okay, so here, if you look again at my terminal, you can see that it just finished installing packages. And so you can see a little bit here, there are a lot of these hex numbers here. So these are container and image hashes that you can see here. And so that hints a little bit at what I said about these incremental, these layered file systems. Basically, one step of this Docker recipe, this builds a container, then there's a way to refer to this container, and then from there one can execute the next step. And so one can imagine that you can build an entire tree, or you can build a graph of things that of things that depend on each other. So you build one container or one image based on previous ones that have been built, and if one is careful enough, then one can make the increments really small, and that helps in keeping things small. So meaning just a few gigabytes and not dozens of gigabytes. Okay, so so then we do the next steps here, and so for the sake of caching, so this is something that I'll not explain in detail. So for caching on the side of Docker, I am copying in parts of the Sage source tree only. I don't copy in the whole thing, but I just start with the first few things so I can run bootstrapping and the /configure script. So I'm adding the top level make file. Why am I adding the README? I don't know. Okay, maybe some script complaints if it's not there. The bootstrap script, and then these things that's using the docker add command. And then finally I run the bootstrap script. So the bootstrap script is what you have to run when you run some arbitrary state of the tree from Git, and so then one needs to run bootstrapping. This runs auto tools and some extra steps that have just recently been added. I might explain about this also a little bit if I have time. So once this is done, I can actually run configure, And so here also there has been, there's a very long configure line that has been built that's basically telling, okay, I want to use system packages for everything. So it's saying, for example, with system cddlib equals yes, and so on. There's some redundancy there, but it's also an automatically computed configure command line. Okay, and this is now running. Yeah, so now the configure of Sage is running in that container, and it is now running all of these things that are referred to as the S-package configure mechanism, right? So first of all, it determines whether there's a good compiler. Yeah, and so in fact, yes, we do have a good compiler there. So how come? Well, I installed it, right? And so let's look behind the scenes a little bit. How did my Docker file know, what the compiler package is called on Fedora? Okay, let's take a look. Yeah, so this is information that is not in the tox.ini, okay, but rather this is now in information in build/packages. So let's see. So this is the, not sure if you can see this. Yeah, so this is the subdirectory build/packages. So this is where all the information about the various S packages lives. But now there's additional information. It's little text files that I have here. So here is arch.txt. That is for Arch Linux, but we were doing Fedora. So we have now here fedora.txt. Okay, fedora.txt knows about the particular package names that are needed as a minimum to build anything for. So these are the minimum build prerequisites for Fedora. Okay, and so for example, it's telling me here, okay, yeah, so I need a GCC-C++ package so that I have a proper, GCC, and something needs find utils, something needs diff utils. All of these things might not be. They might be in standard desktop installation of Red Hat or Fedora, but they might not be in the kind of minimal OS images that I pulled from Docker there. Yeah, and so here I have a record of the minimum build prerequisites. Yeah, so this is found experimentally. Yeah, so basically based on what was previously documented somewhere, or hearsay from Sage support, Sage devel, and so on, maybe from scraped somewhere from the wiki. Yeah, so this is now part of the source tree, this kind of information. Yeah. So there's like now one file that records the minimum build dependencies on a Fedora. Yeah, so Fedora, CentOS, Red Hat, this type of thing, and so that's how it comes that I had already the right GCC package on here, and now my S package configure detects it. Yeah, and it tells me, yeah, okay, we'll use system package, not install the S package GCC. Yeah, so this is good. This will shave a lot of time off the compilation time. Yeah, and so these kinds of mechanisms, they were in Sage for quite a long time for GCC and for G4tran. But this effort that I referred to started a few years ago by a number of people. This made this very systematic, transformed kind of ad hoc code in the configure scripts, or in the configure AC, into something that happens on a per package basis, and it's nicely structured. Yeah, and so it continues tests for MPIR and for various other things. Yeah, boost and so on and so forth. Yeah, so you might ask now, boost, okay, we didn't see that. Yeah, boost is not a minimal a build requirement, and in fact, it was not listed here. Yeah, and in fact, if you think about it, yeah, so we have hundreds of packages. Yeah, and if you imagine this text file having 300 300 entries for the desired build prerequisites, on a Fedora, this would be rather unmanageable. Yeah, I mean, you see a forest of 300 packages. You don't see on on one look whether something is there or isn't. Yeah, so that's why things are structured in a different way. We already have all of these subdirectories here in the packages directory. So for boost, for example, so we have boost and boost cropped. So let's look at this. So boost, so we have this spackage.rst, soon spackage.rst. That talks about this package. Yeah, but so boost is the name of our S package. Yeah, and so what we need is a mapping from the S package to the OS package. And so this is now new information that is here in the subdirectory distros. This records, okay, here fedora.txt, and it tells me, it's a very short file. It just tells me, okay, I need boost -devel. Yeah, and so that's the package I need on Fedora. Yeah, so there's one short file, and so having this there, isolated like this minimizes a possibility of merge conflicts when changes become necessary. It's better than having this long list of packages somewhere in some file. It's the same thing for Debian. Yeah, so there the name is libboost-dev. Yeah. And so, these are the kind of information. Yeah. So again, this was things that was known to experienced developers. Yeah, on that particular platform. Yeah, and basically there were like on Sage Devel or Sage support, there were like hundreds of these threads where it would be like someone asks, oh, how come we don't use that boost from the system. Yeah, and so then Dimas Pasechnik would reply, well, on Fedora you need boost-devel, yeah, or someone else would reply, well, on Debian the name of that package is so and so, or or we would send people to look things up somewhere. But now we have this information right here in the source tree. Yeah, so because Sage is so has so much information already about these S packages. Yeah, so we can now also store the information about the corresponding system packages, and so this helps both to inform the user, but also allows us to set up these testing environments in a systematic way. Yeah, I can say, okay, I want to test against a Fedora that has the system package for a boost installed. Yeah, and instead of saying I want a Fedora where I install what was it called, boost-devel. Yeah, and so it's a level of abstraction that helps in setting up these build environments systematically. Yeah, and so this is what happened here. And so this succeeds. So in the end, I see there's a report from the configure script, what packages were all found in the system and so on. And configure ends somewhere. And so in fact, some of you already compiled Sage 9.1 or some recent development version before. This information about system packages is also used at the end of configure. Those of you who don't run configure but run make, this might scroll away and a build might start already. So that's why it's a good idea to actually run /configure explicitly these days. And soon we might actually make this a requirement. You see at the end here, it's displaying some hints about packages where one didn't find suitable equivalent system packages. Yeah, so this one is in terms of the S package names. Yeah, but then there's this translation layer that comes in. So here it figures out that we are on Fedora. Yeah. And then it's telling us, okay, so the translation of these packages to system packages is this, and so it tells us it doesn't execute these commands for you. Yeah, so it's not going to play a system administrator. It doesn't sudo into your system and install anything. It's just this is the user education department, right? This is just telling you if you want, you can use the yum command to install the following packages, and then installation with Sage might be going faster, might be smoother. Yeah, and so this is what happens facing to the user, but it's also happening right now in my container. Yeah, so that's what's happening here, and then again I continue with some more steps. I'm setting up which packages should run their test suites, and then I'm calling make, and so it's building something. Building, and so here it's building something. Oh, okay, so there we see LRS lib 062. There's a problem here. Yeah, so there's some problem with libp thread. Yeah, so that's exactly what I'm talking about. This is a portability problem. Yeah, so there's one package, LRS lib. Well, it's an optional package. Yeah, optional packages don't have the same support status in Sage. The release manager never tests optional packages, for example. Yeah, and so it's you know, one needs to take a particular care that the optional packages that we care about, that they are supported on enough systems. Yeah, so LRS lib didn't get this kind of care apparently for 9.1, and so it fails on this particular platform. Yeah, with a p thread related error. Yeah, and so that's where it goes. So we see it's talking about, yeah, so it's we have the logs here. Yeah, so there's the build log somewhere. So now take a look. This is a very strange path here. Yeah, so it looks like it's in /sage. Yeah, this definitely doesn't live on my Mac. Yeah, so this is a path inside of the Docker container that ran here. Yeah, and if one wants to debug this, one basically needs to go into that container and do that. And so this is what we can do. We can now interactively. So actually, this failing build here, this actually using the docker commit command creates an image that we can resurrect. So somehow, the container died at this point. Yeah, but so it's it stopped after this make command, but I can run this again, or rather the state of the file system that was there, and let's just run a bash in it. Yeah, and so now I am a root. Yeah, so there are no user inside of this this container. I'm just root. Yeah, so I have here ls-l. I have a Sage here directly under root. I'm already there, and so I can look into my container. So this is yeah, so this one here is a Linux that's running here. It's running here on the particular Linux kit kernel in this case, and so this is that Fedora that I just built, and so there's my Sage. There are my logs. So I can go into here and inspect things. Yeah, so can try to use less LRS lib, and okay, turns out something happened here. Yeah, so I can scroll here, get my stuff. Yeah, so that's one way I can do this. Yeah, or again, let me emphasize, this is all running on my Mac here. Yeah, so I can also do this in airplane mode. Yeah, so this kind of debugging. Yeah, so this enables system debugging on multiple systems, even when we are flying on an airplane. Let's see if we can ever fly again. But so we'll see. Yeah, and so I can just do Control D out of this container, and so I'm back on my Mac at my Mac shell, and so I can do more stuff. Yeah, so this was all automatically done by just this command tox -e docker fedora 30 standard LRS lib. Yeah, and so let's do this again. Let's do this just like this without further options. And so I'll show you some of this this caching that is happening here. So if I do this again, then what should happen is, so again, it's sending some information to something called the Docker daemon. But then lots of these things that took a while before, they are cached. They are using these digests here. It's detecting that, you know, I've already installed all these packages, so it's just retrieving this from the cache, and so everything is already configured, and so it starts to build Sage packages. Yeah, so this just took a couple seconds. Before this was a number of minutes, and I had to talk about all of these things until it was done installing things. But now this was cached, and so I can go directly, you know, into part of that build. Not continue this, and we just do Control C. Yeah, so okay, yeah, so this is done automatically, and I can do this now on different platforms. I can do Docker, Ubuntu. Ubuntu what? So let's look it up. Toxini. Maybe do Ubuntu Bionic, yeah, the old stable release here. And so instead of standard, I can also say, I want to test this thing in a minimal configuration that only pulls in, you know, the absolute build, yeah, so the minimal build prerequisites. Yeah, and so that's what's in that short text file that I showed you before. So I can do this again. Yeah, so it's writing a Docker file. Actually, let's take a look at where this is taking place. So everything Tox is doing is disposable. Yeah, so it's not contaminating your work tree very much. Okay, so the logs are shared, so that's happening. But yeah, so anyway, there's a .tox subdirectory. You can see that here. And so this is where all stuff goes. Yeah, so this is where temporary things go. And for example, on the Fedora 30 build that we did, there we can see the old Docker file. That's just this auto-generated Docker file. It looks terrible. Yeah, this is something of the type that you do not want to maintain manually. Yeah, and so this is automatically generated from this package database, from this you know, system package database with the different build steps and so on and so forth. Yeah. And so now we have the same thing for the Ubuntu Bionic that's running the terminal. It has already created the Docker file. So we see this, there's a base image here, and then there's a list of packages that we want installed. This list of packages is much shorter now because, yeah, we are doing this minimal build and then various steps and so on. So we see package installation was faster, so it's already in the bootstrap phase, and now it's doing the configure phase, and it's so let's see what's happening here. So it's, for example, it's telling me you have boost. There's no system package. Well, okay, yeah. So tough luck. So we'll have to build the system. We have to build boost ourselves, at least the small version, the boost cropped, and so on and so forth. Yeah. So we can test this, and so it already starts building these things. So if I want to do this in parallel, I can do, so Tox is, it isolates the environment, and also the Docker thing is isolated, but some environment variables are passed through, and one can make sure to pass other options through. For example, I can say, okay, I want to do builds here in parallel, and can pass things through here. So anyway, so actually this one was already doing some things in parallel here. So okay. Yeah, so that's what I have here. So yeah, so takeaway points. There's a standardized way of talking about various system configurations. Yeah, so Docker is the technology that we use for testing. Then there are nicknames for various systems. There's Docker. You know, there's Fedora 30. There's Ubuntu something. There's Slackware dash something, and then there's another you know, factor indicating what kind of set of system packages to install, and based on that, and based on, you know, the database of system packages that we have here, it builds these kinds of things so we can run these tests. Yeah? And so this is what you can do completely locally. Yeah, on your Mac you can test various Linux things. Yeah, and so that's that enables basically a new workflow if we want to you know, support systems that some users have access to. Also, for example, what is it that might happen here. It might happen. So let me bring this up. It might happen like it happened on March 17. That someone tells us, okay, so we have a problem here on a Linux that many people probably have not heard of. It's like one of the classics from long ago that apparently still exists and is still maintained. So Slackware, a very, very unique C Linux distribution, and so it was reported to us, so that Sage 9.0 does not build on that machine, and so traditionally we would have said, oh, well, okay, is there any Sage developer who has this system, or maybe if the user is insistent enough, maybe then a developer would ask, can you make an account available for us on that machine, or send us this log, send us that log, could you try this, could you try that, and so on. But now we have a better workflow for these things. So when a user cannot build Sage on a particular system, then what we want to do is we want to fix this portability bug, and we want to make sure that it stays fixed. And so what we want to do is we want to set up a maintainable a way of setting up these test environments, and so this is what I did in a response to this ticket here for Slackware, right? So there are a number of files that one needs to touch in order to do this. For example, there's in the build bin, there's a little script that is called a SageDays system. So this is what I can run on a container. You imagine, someone drops us into an unknown container, and I get some strange shell, and we have no idea how to install packages there. But now there's a script built in SageDays system, and it's just let's just do this. So let's just do docker run. So this is interactive with the terminal of I don't know. Let's look it up. So this one is not the automatic version here. So let's just do this manually. So run the Docker image here, vbat Slackware 14.2. So it downloads this thing from Docker Hub, 35 megabytes. Okay, we're now in some shell. And then okay, I'm stuck. So so I don't know what app to get. Okay, it doesn't work. So we have to guess. But now we have this script. And so basically for every package system that we want to support, we just extend the script a little bit. So this script knows about it knows about Conda, it knows about Homebrew, it knows about Gentoo, Debian, Fedora, Arch, Slackware now. So basically for the Slackware support, I had to add these 2 lines. So somehow by Googling, one finds that the relevant package tool is called Slack package. Okay. So learned this once, and so this happens now here. And so this is both for we can find this out as users now. If you have to debug things there, but also our scripts for testing use that information, and then one needs to set up in the tox.ini some relevant, the relevant names of the images that we need, to the base image of the operating system, and then little things like this. So it's a couple of lines of changes that are needed to support a new system there. And then we can on our own development machines actually debug any portability problems. We can replicate what is the problem there. Make enough system packages known to our S package to system package translator and so this this then allows us to replicate this, and so we added to this in docs.ini, and then the next step actually is that based on that we also have continuous integration, running on GitHub. So this is all of this is let's say quite orthogonal to what Julian demonstrated. Basically, Julian showed something that is able, kind of with a fixed configuration, so it's always running on the same operating system image, is testing many branches. Yeah, and so here we have now CI, so continuous integration infrastructure on GitHub Actions, that uses this kind of TOX workflow to test on various systems automatically. So let me see what is the right one here. So this ran automatically for 9.1, and so let's look at this one here, for example. So so I'm not sure if you can see this, but so this ran here with Docker. It ran on the various Ubuntu variants. So this is Ubuntu Trusty in the minimal configuration. It ran it in the standard configuration, and then so on. This one is the standard Python 2. This is now going to be removed. We have Ubuntu Xenial, Ubuntu Bionic, Ubuntu Focal, Debian from Jesse through SID, Linux Mint, and so on. So these are all run. Yeah, it takes a couple of days to go through everything, but this is all on basically on free compute. Yeah, so that is provided by Microsoft on GitHub. So basically every user gets access to basically 20 VMs. The pro GitHub account users, they have like 40 such VMs that are available at any time, per user or per repository or something. And so we can run all of these things here. This runs automatically, runs the test suite, and in the end, this produces megabytes of logs that we can inspect. There's like an interactive view on this, and so we can look what happened here on Fedora 28 standard. So logs, and all of this is documented. I've written a little section in the developer's guide. It's called Testing on Multiple Platforms. I'll share the link somewhere as well. So this takes you through this whole process, doing things manually on Docker, then using this this system package and system packaging system knowledge, such as this Sage guest package system, and there's also a corresponding Sage print system package command that allows me to discover the correct command to install something. Okay, so everyone knows apt-get, yeah, but and this takes you all the way then to advanced topics. What one can configure is that this automated testing on GitHub Actions. This runs on every not on every commit, but it runs on every tag that you push to GitHub, and so you can do this in your personal fork of the repository. So it gives you an independent way of testing on all of these platforms. I highly recommend this whenever you make overarching changes to the to the build, such as upgrading any packages. Yeah, so which will always break at least one platform. So basically any such ticket that it makes changes to either the S package configure or makes changes to a version of the S package should go through this kind of thing. And so what one can do is actually these Docker workflows that are running, they don't throw away what they built in the end, but actually similar to what Julian showed for his workflow there, it builds things that one can pull, so to continue debugging things on the local computer or on some other host. So let's look into my fork of the Sage repository. And so here in the Actions tab, we see the various actions, but there's something else that was created by the actions, and you can see this in the Code tab, that is Packages. And so you can see it built a package for me that's called Sage, Docker, Ubuntu, Bionic, Maximal with targets optional. And so this is like, it's like a result of a big build with lots of installed system packages and with lots of optional packages. I can click there and it tells me basically Docker pull command, so I can pull this image. It's a multi-gigabyte image, so it's not recommended if you're connected, through broadband on your phone. But if you're on a fast connection, you can just pull this image to your computer and then do local debugging in this thing. Yeah, so there's lots of details that you can read up in my tutorial, part of the Sage 9.1 developer documentation. That's where I stop. Let's see. I'll stop sharing my screen. And so, are there any questions? Yeah, please unmute yourself if you have questions. You keep an eye on the schedule.
Yeah. So I know that when I set up this these GitLab things I showed before, there was some discussion, and back then whether we should go for GitHub, which is more popular, or GitLab, and some people are very reluctant to go with GitHub because it's not open source and so on. I mean,
sure.
I don't care, but I know that.
So this is an important point. Yeah, of course, one doesn't want this kind of like commercial vendor lock-in. So that we build complicated infrastructure that somehow depends on peculiarities of a system. And so this is also actually something that basically I'm only using the GitHub because it provides a rather generous free compute. But the complicated bits of the whole thing, they're done using purely open source things. So I'm building these Docker recipes. And you can run these Docker recipes on anything that if you have your own Kubernetes infrastructure, you can run it there. And so basically the question of so there are all of these different CI infrastructures. There's the Travis CI, there's the GitLab CI and whatnot, and they all have their idiosyncratic ways of provisioning the system. But for this particular testing application, doing basically this portability testing, this is exactly what we want to have control over. And that's why I'm doing these things based on these Docker containers. So I have complete control over that, and I just need to have anything that can run Docker. Right now I have this on GitHub. I can show you. Let me share the screen again. I show you basically how the amount of code. It's not very much code. So a lot. There's really lots of these things are kind of multi-use. There's this system package translation layer that is used both for generating documentation, for informing the user at the end of /configure, and for setting up basically the build system provisioning. And so this is not specific to the CI system there. And also the TOX. So the TOX is free software. The TOX is it's 380 lines of code in the tox.ini. So it's short because of this very elegant factor thing that TOX provides. Basically string together these various flavors. So I haven't really shown everything, but I have also like a configuration factor that says, okay, configure this thing with a Python 2. It's just another -Python 2 in my string of factors there. and so have some complicated things from macOS too, and so on. Yeah, so there's the tox.ini, and now I show you what is specific for the GitHub CI. So this lives in .github/workflows, and this is really very small. Yeah, so they have a.
I think you're not sharing screen. At least I can see it.
Oh, okay. I thought I clicked this. Oh, so share.
No.
Yeah, let me see. There we go.
So yeah, so my question was also, so I was curious, is there anything?
Can you see it now?
Yeah. Is there anything like, do you do Windows testing, like Cygwin testing on GitHub Actions?
Yes.
Well, or?
Yeah, I think we still have a couple of minutes. I think next talk is at in 25 minutes or something. Yeah. So I'll just keep talking. So let me just look at the tox.yml. That's the recipe for the GitHub CI, and so that's really minimal basic. It's so there's some YML that tells me, you know, when should this be run? Yeah, on pull requests it should be run, and on tags it should be run, and then you have a list of the targets that I want to test. Yeah, so I have
very similar
this list from Ubuntu Trusty. Yeah, and so these things, yeah, they refer. These are my nicknames. Yeah, so they that goes through this reusable translation layer. Yeah, and so I'm just using the nicknames here. This is. And then there are these steps here. Yeah? So it's just a couple dozen lines of code here. That's the recipe for Linux. Yeah. I have so I didn't have a chance to explain this before. Other than this Docker technology in my talks, I also have a local technology that's basically for running things on the computer without virtualization. I have that for let's look this up in the tox.ini. Yeah, so if I'm running on a Mac, I can do some homebrew provisioning. So instead of depending on whatever might be in the in my homebrew installation user local, this is actually provisioning more or less isolated, separate homebrew installation just in the .tox subdirectory, and it's building against that. So again, I have therefore with my scripts full control over the homebrew configuration. So what packages are installed there? Yeah, I can show you quickly as get out of the Slackware and to the tox-e local homebrew macOS standard. It does that, and so it's doing that. Yeah, so it's installing a little homebrew somewhere under .tox, and this takes a while. So it provisions that here. Yeah, and this is all disposable. Yeah, you can just clear out that .tox subdirectory, and then all this multi-gigabyte mess is gone. That's how I can run various flavors of homebrew configurations as well. Yeah, so without having to uninstall packages, install packages, and so on. I can have them all prepared. They will be reused because they live in different subdirectories corresponding to the environment in my .tox. Yeah, so I have one work tree of my Sage sources. But for each of these configurations, so I had these Docker thingies, but now I have my local thingy as well, local homebrew macOS standard. And so here it installs homebrew into a completely isolated hierarchy. Yeah, so there's homebrew, bin, brew, and so on. And this is where basically the build happens. It's using the same source tree in this case. Yeah, so the Docker is completely isolated. This one here is only semi-isolated. It still uses the Sage source tree. So that's something. But now let's look back into the tox.yml. I'm running these things now. So this is now the local macOS. This is now running these. So and again, yeah. So it's this is specific to the GitHub. But the actual hard work is done by just a tox-e command. which runs the provisioning of the homebrew and so on. Yeah, so again, I am not dependent there on the particular idiosyncratic configurations that the CI might provide for my macOS. Yeah, but I have this under good control with my isolated homebrew installation that I have there. And then there's just some stuff that is for like printing logs and packaging up logs to make things convenient for debugging. I have something also for like Ubuntu. And so you asked about Cygwin. Yeah, we also have some Cygwin. This was a little bit of a pain because GitHub Actions is generous. So you're getting basically 6 hours of compute per job. That works for building on a standard Linux target, a whole Sage from scratch, and do a make p test. But Cygwin is much slower, and so we can't do this in one go. And so what I have there is, so this is something that so you can't run this in a Docker on your Mac, but you can run this on the GitHub runners that run on Windows Server. And so this is this is all running in the Azure cloud, of course. And so this is using a different workflow. So there's a different actions thing. So I have here CI Cygwin standard. Yeah, and so I have separated these things into separate stages here. So there's like 6 hours worth of stage 1 and another copy of stage 1 and so on and so forth. Stage 3 in the end succeeds in building all of SageLib, and then there's some testing on top of that. And there are, it's not super robust, but of the various configurations that I'm testing there, there's usually one that goes through. So I have good confidence that the Cygwin build of 9.1 just works. So we have something there, but it needs some refinement. Okay, more questions?
How easy would it be to move this Cygwin build onto a dedicated Windows machine?
So let's see. So if I wanted to do that, so I would suggest to first refactor this a little bit. Right now, what I do on Cygwin is not using tox at all. So I would probably say, it's not really required, but it would make things a little bit more reusable to refactor this. So this just becomes another another flavor in the tox recipe. And then, I mean, so if you set up a, I'll show you a little bit the script for the Cygwin. So it looks like this. Also, this script here, there's a lot of copy paste. So I didn't have time to do refactoring on this one. So this is all through many iterations of hand copy paste and so on. Yeah. So this is not in such a good engineered shape, but it's doing the job. Yeah, so let's see, what am I doing? I need to install Cygwin on the host. Yeah, and so there's a nice thing called Chocolatey, and so that's the easiest way to actually install a Cygwin. Basically. So this command here, without any interaction, installs a Cygwin. Yeah, instead of having to go through this crazy setup x 68 x86 64.exe thing, it sets up the Cygwin. And then we can install the additional packages that also just go through choco install of my packages. Again, the packages are coming from cygwin.txt files. Yeah, so I have already here the translation from, again, my S packages to the names of the packages on Cygwin. So again, one doesn't need to maintain this list anymore in many different places, but it's all coming from the from the distribution, and then one just starts bootstrap and configure. Yeah, so you really just need a Windows machine. So if we have our own runner, then we wouldn't need the free compute, then we would need someone who pays for it and who runs it. Yeah, I mean, it's easy to set up these own runners on Azure. Yeah, and I mean, so
yes.
People have acquired this free compute, from what, Google Cloud, and from I don't know, from Amazon perhaps. To me, these things are on the same footing as the free compute that is attached to basically the GitHub CI. We are using that as provided by these companies, as part of their free offerings, right? So yeah, but many different solutions are possible, and if you can find better ways to provision these things, that is less dependent on a kind of free compute provided by our corporate overlords, then even better. And so my I guess my design principles that I used here made things easier to move in this direction by keeping as many parts of this whole mess basically in a reusable way, multiple purpose way. So testing, documentation, and user information, and so on. So that we have this kind of maintenance intensive information that we can keep this in one place, and generate stuff from there. More questions,
well, I mean,
comments?
I just want to comment that I think some universities might have use of free resources on Azure. So this might be a possibility to run SageMath build in a meaningful way without this multi-stage headache.
Yeah, I mean, so the headache is done already. Yeah, so now I had all of these headaches already. So the multi-stage works. There's one can do some refactoring, and there's actually it's an exercise in combinatorial optimization there. How does one input the dependency information, output and also estimated compile times, output best partitioning, shortest makes span. So it's in our area of integer programming, of course. But yeah. So if we have more compute available, so some so these what we have here are just two core hosts. If we had fatter nodes, with where we can run 16 parallel threads or so, then we can speed up all of these builds, of course. And if you don't have the 6-hour time limit, then things become faster too. And I should also say these. So the contrast to Julian's infrastructure there is I'm not doing anything there regarding incremental builds. Yeah, so all of these things are from scratch builds. Yeah, of Sage. So this is of course extremely wasteful. Yeah, but it's for this particular purpose of portability testing. Yes, one doesn't want also to add somehow the variability through to incremental builds into the equation. But if one wanted to integrate this, there's probably some things that I would want to discuss with Julian, to make sure that these the layouts of these Docker images and containers are at least compatible, so it makes so it becomes easy to build something with one of the tool chains and then switch it over to the other one. with some mild, changes to, like install locations that might be possible. And then one can think also about, speeding things up through incremental stuff. More questions, comments?
There were 2 questions in the chat. Not sure if you've seen that one.
Chat, where's the chat? I don't see the chat.
I can just read them out to you if you want me to.
Thanks.
So Mark Bell asks, does this help to ensure that builds are deterministic reproducible? It looks like you have control over the dependencies, but if Docker is automatically pulling down the latest versions of some dependencies, then these might change between builds.
That's right. So, okay. So let's see. So right now, the focus of what I have developed there is not on reproducibility, and also in particular, it's not really targeted to producing output that would be used. Yeah, it's really, these are throwaway builds that we build just to check if it builds. And if one is interested in reproducibility, then one would make several more adjustments. I mean, these package databases of the various distributions, of course, they change over time when the distributions update, and also the installation. This might depend in a subtle way. Sometimes there's a network error, and then some package is not installed. And on some build systems, there's a fatal error. On others that just silently continue. And so you don't get immediately a reproducibility from these builds, but this was also not the goal of this. I guess one can arrange for reproducibility, but this goes more into the direction of what Julian has been doing. Basically, you write your specific Docker file. Yeah. So I mean, if you use your image and tag, and you use your tag with a specific hash, yeah, then you can get a particular version, of course, yeah. But then you need to make sure, for reproducibility, that you also you don't use from the package from the package databases anything that will change over time. Yeah, so it's a separate issue. It's an important issue, but it's not really addressed by this. More questions?
Yeah, there was another question. I think it's mostly answered already by John. If I want to use Docker locally on my Mac, is there any guidance about which system targets to test first? Which ones give you a good representative sample of potential problems? And Dima answered basically a recent Debian, one recent but not too recent Fedora, Arch. I mean, maybe you can add to that.
So let's see. So my take on this is you can't really predict it. So basically, when I started this project, beginning this year, so with 9.0, I had the impression that essentially Sage would not build on any system. Yeah, so for example, the Fortran, so at least, with like minimal system configuration, like what we documented as like the minimal requirement, basically it would build on nowhere. So it would try to build the Fortran compiler, but that was completely broken, untested, and therefore broken. And so this took lots of iterations, lots of tickets, where several of us made lots of changes then to address these things, so that we arrived with the 9.1 at this list of supported platforms. I'm not sure if I'm still sharing my screen. All of these, Ubuntu and Fedora and whatnot versions. And so general concern is about really old versions and really new versions, but there are nasty surprises everywhere. Sometimes a version in the middle where something was messed up but it wasn't deemed important enough to fix in Fedora 31 or something. So it's about rule of thumb is it's the really old ones and really new ones that are causing biggest trouble. We still have big trouble with GCC 10. So just around the time that we were finishing up the 9.1 release, as you know, Fedora 32 came out with already using GCC 10, and various of our packages don't build. And turns out also GCC 9 that we are on as an S package did not build with the GCC 10. So some last minute adjustments had to be done. And so these are really new things, and some really poorly maintained upstream packages cause some problems. And so I think we need to stop here, I guess. I'll be around for the rest of the event here in the Pacific time zone. So let me stop the recording. Or who's recording?
I can stop
Samuel,
it.
are you?